So in this video, let's look at some examples in relation to what we have answered, what we have actually discussed in the previous video. Here now the question says, how many grams of copper in bracket 64 gram contain 4.5 times 10 to the power 23 atoms? So in this case, you already know that you have the number of atoms, but you don't have an exact idea of how many grams of actually the copper contain this 4.5 times 23, 4.5 times 10 raised to the power of 23. So you want to know how many grams of the copper will contain 4.5 times 10 raised to the power of 23 atoms. So I think, ladies and gentlemen, there are two ways that you can do the calculation. So we know that number one, that as I said, one mole of every substance contain Avogadro's number. It means that one mole of any substance contain 6.02 times 10 to the power of 23. But in this case, actually, we are trying to, of course, under ideal condition, is that, of course, since the mass of copper is 64 grams, so it means that although there are two ways that you can do this calculation, and I think let me apply all these two methods so that at least you will know how to solve such kind of problem. So number one, you see, we know that mole is equal to number of atoms divided by 6.02 times 10 raised to the power of 23. So here we're already given the number of atoms, which is 4.5 times 10 raised to the power of 23, then divided by the Avogadro's number, which is 6.02 times 10 raised to the power of 23. So you see, we already have the number of atoms, but what we want to get is the grams. In how many grams of copper are we going to get these 4.5 times 10 raised to the power of 23? So I think from here you can calculate the number of moles. Then after calculating the mole, you can calculate the mass. So therefore, this one divided by this, when you divide it, it's now going to give us, of course, 0.75 times 10, 0.75 mole. So we are going to have 0.75 mole when we divide this by this. But what we want to get is, of course, the gram. It means the mass of the substance that contains this. So therefore, of course, we can use the other formula, which means mole is equal to mass all over molar mass. So we already have a mole, which is 0.75 is equal to the mass. So our mass here is X, which is unknown. Let's say it's X. We now have X divided by the molar mass. So the molar mass of copper is 64. So it's 64. We are now going to cross multiply. So therefore we have 0.75 times 64. Then we now have is equal to X. So therefore we are now going to multiply 0.75 times, of course, 0.75 times 64 times 64. So therefore, we are going to have 47.84. We have X here is equal to 47.84 gram of copper. So it means that in every 47.84 gram of copper, we are going to have 4.5 times 10 raised to the power of 23 mole. So, ladies and gentlemen, the relationship is not actually only between mole, mass, and the number of particles. The relationship can also be in the form of volume. Because under standard condition, one mole contains 22.4 dm³ volume. So therefore, a mole can also be expressed as volume all over 22.4 dm³. So it can be given your calculation in volume, and you can actually be asked to calculate the number of atoms that are present in a given amount of a substance. So I think it's simple. What we are going to do now, of course, we can say that, okay, let's say we can decide to say, okay, how many atoms are there in in 2.24 dm cube of oxygen? So this is the question. So you want to know how many atoms are we going to get with the volume of 2.24 dm cube of oxygen. So we already have the volume of oxygen. So we want to know how many atoms are we going to get in every 2.24 dm cube of oxygen. So it's simple, ladies and gentlemen. So applying this formula, we say mole is equal to volume all over 22.4. So volume all over 22.4 dm cube. So we already have the volume here in dm cube as 2.24. So we can now say 2.24 divided by 22.4. So if you divide this by this, then we are now going to get 0.1 mole of oxygen. So we already have 0.1 mole of oxygen. So now, since we have 0.1 mole of oxygen, so how are we going to get the number of particles that are present in the 2.24 dm cube? So it's simple. We can now say, okay, since here is 0.1, so we can now say 0.1 is equal to the number, because we want to get the number of atoms. So the number of atoms divided by 6.02 times 10 raised to the power of 23. So I'm now going to cross multiply. So this 6.02 times 10 raised to the power of 23 times 1, then the number of particles times 1, so the number of atoms times 1. So this implies that the number of atoms is now going to be exactly as, if we now multiply this times this, it's going to give us 6.02 times 10 raised to the power of 22. So it means 22. So if we multiply this times this, then it's going to give us 6.02 times 10 raised to the power of 22. So it means that in every 22, so in every 2.24 dm cube of oxygen, we are going to get about 6.02 times 10 raised to the power of 23 particles. Okay. So please, I just wanted you to try these questions so that you can put the answer on the comment section. But now, how many ions are there in 13.5 gram of copper 2 chlorides, CuCl2? So the mass of copper is given as 64. The mass of chlorine is given as 35.5. So I think based on the examples that I gave, I think we can simply calculate the number of ions that are present in the 13.5 gram of chloride. So, ladies and gentlemen, we will now meet in the next video. I hope this video will be of importance, and if you have any questions, you can actually put it on the comment section. Thank you.